everyone. My name is Ayushi Agarwal. I am Assistant Professor from Department of Computer Science and Engineering of ABES Engineering College, Ghaziabad. Today in this video lecture, we will be discussing about DFA, graphical representation of DFA, formal definition for DFA, and some example questions based on DFA. So, what is DFA? The full form of DFA is Deterministic Finite Automata. This term deterministic basically means that it alludes to the uniqueness of the calculation. So basically a DFA is a tuple machine which accepts the strings, input strings by reading one symbol or one character from the input string at a time. So that means it will show the transition from one state to another state by reading one symbol from the given string at a time. So in a DFA, there is just a single way for explicit contribution from the present status to the following state. That means it will follow a single pathway or one direction way by reading one symbol at a time from the given input symbol. And a DFA will never accept the null transaction or null move. So if a symbol or a character is not read by the DFA machine, it will not show any transaction or any transformation from one state to the another state. A DFA may contain multiple final states. So there can be more than one final state for a given DFA, for any drawing DFA. Application for this DFA is used in lexical analysis in compiler. So what is lexical analysis, what is compiler, we'll discuss in the videos related to compiler. Over here, we just need to understand and learn that a DFA is having an application in lexical analysis in compilers. Now, let's move on. And this is the graphical representation for DFA. So over here, let us understand how the graphical representation of DFA is important to answer any question related to DFA. So let us see over here. I have shown three states over here. This circular structures are known as states. So any state we will show in a circular structure. And every state must be named or numbered with the help of a variable. Either you can name them as A, B, C, D, and so on. That means you can use the alphabets. Or you can name them with the help of numbers, 1, 2, 3, and so on. Or you can use this method as I have shown in the diagram, that I have concatenated the combination of alphabet as well as the number. So you can use either of these three methods to name the states. But the important thing is that naming of the states is important. Without naming the state, it is not the correct form of DFA. Now, let us understand every denotation of this particular DFA. So this state Q1 is our starting state or initial state. Starting state or initial state. Why I am stating it as starting state or initial state, or how I have identified that state Q1 is our starting state or initial state? Because this particular state is having this empty arrow. Why I am stating that this is an empty arrow? Because this particular arrow is not coming from any state. It is not coming from any state. It is just an arrow which is attached to this particular state, showing that this particular state is our starting state or initial state. So every DFA diagram or every transition diagram for DFA will always have a starting state, and that particular starting state must have an empty arrow with it. Next, let us move on to this state Q3. This state Q3 is having two circles. One is this inner circle and another is this outer circle. So any state having two circles is always a final state. So this is how we denote differently the initial state and the final state. Initial state will be having an empty arrow and a final state will be having two circles. Next, this state Q2 is the intermediate state. Some intermediate state or any number of intermediate state will be denoted like this. It will not have any double circle. It will not have any empty arrow, right? So any number of intermediate state will be denoted like this. Next, let us discuss about other these arrows. So as we have stated that a DFA will have a transaction or transformation from one state to another state, as it shows over here, that there is transformation or transaction from Q1 state to Q3 state. But via which input variable? Via single A or input symbol A. So by reading input symbol A, Q1 state is having a transaction and moving to the symbol Q3. Similarly, from Q1, it is reading Q symbol P and moving to the another state Q2. Now, the question might arise among you that why we have not moved to the same state Q3 by reading symbol P. If we are reading A and moving to state Q3 via Q1, so in a definition of DFA, we have stated that our transaction will be like from one state to another state by reading one symbol. Okay, so in a DFA, we cannot read two symbols together on one transaction arrow. That means we cannot move by reading multiple symbols, multiple type of symbols and move to the same state. That means by reading A and B both, we cannot go to state Q3. That is why by reading B, we have moved to some other state Q2, and by reading A, we have moved to some other state Q3. Okay, now the question might arise that why then we have shown this arrow with multiple symbol A comma B. So in a DFA, only the final state might accept multiples input on one arrow. Only the final state will accept this type of combination of inputs. Other than that, no other state or no other transaction arrow will have multiple inputs on it. So this is the graphical representation for a DFA. By this, let us first understand what is the formal definition of DFA, and then we will correspondingly understand every point of formal definition of DFA with the help of this diagram. So this is the formal definition of a DFA. So basically a DFA is a 5-tuple machine. So these are the 5 variables that are stated in this tuple. That is why we are stating a DFA is a 5-tuple machine. So first variable is Q. Capital Q denotes the finite set of states. Sigma is the finite set of input symbols. Q0 is the initial state, F is the final state, and delta is a transition function. Now let us try to understand all these 5 symbols with the help of the same diagram. So over here, let us understand each variable of our 5-tuple machine of 5 tuples. So Q over here denotes the set of states. So this is Q1, Q2, and Q3. Next comes the sigma, that is the input symbols. Over here, input symbols are A comma B. Then comes the Q0. Q0 is the starting state. Over here, it is Q1. Then comes F. F is the final state. Over here, it is Q3. Then comes the delta. Delta, transition function, which is very important to understand and to how we can write them. This is the equation. Now let us understand this equation. This equation states that there is a state Q. Obviously, Q is a set of states present in a state diagram. So where Q can have a value as Q1, Q2, and Q3. Sigma have the value as A comma P, and again Q will have Q1, Q2, or Q3. Now let us write a transition function for this particular diagram. Over here, first we have starting symbol as Q1. So let us start with that one. Q1, when the Q1 will read is reading symbol A, it is moving to a new state Q3. When Q1 is reading symbol B, it is moving to a new state Q2. Coming to state Q2. From Q2, there is no transaction shown going to another state. So obviously, we will not write any transition function related to it. Coming to the another state Q3, by reading from Q3, by reading A, it is moving back to the state Q3. From Q3, we are reading B and coming back to the state Q3. From this also, we can identify that Q3 is our final state because only final state can have multiple inputs on its arrow in a DFA. Other than this, none of the transaction arrow will have multiple inputs. So this is how we can write transition function for a given transition diagram. Now let us understand how we can write transition table for a given DFA. This will help you to understand further example questions. So over here in the first column, we will write all the states available to us for a given DFA. Over here, we have 3 states. So let us write them, Q1, Q2, and Q3. Q1 is the initial state or starting state, so we'll keep this with an arrow. And Q3 is the final state, so we will keep a star with it. So to identification or to identify which is the starting state and which is the same ending state, it will be easy. Now from Q1, by reading A, it is moving to the state Q3. By reading B, it is moving to the state Q2. From Q2, no variable is read, so we will keep it as a 5 over here. From Q3, A going to Q3, from Q3 reading B going to Q3. So this is the corresponding transition table for this given DFA. So over here we have understood 3 terms: transition diagram, transition function, transition table, and a 5-tuple machine. So this is the graphical representation and formal definition for any DFA. Let's move on to the example questions. This is the first example questions. Let us see over here. This is a transition table given. This first column states the number of states that are available to us. This is the transition of states by reading symbol 0. This is the transition for states by reading input 1. So now let us draw corresponding equivalent transition diagram for this. So we have Q0 as the starting symbol. So let's draw the Q0 state as a starting symbol. By Q0, reading 0 coming to the state Q0. By reading 0 coming to the state Q0. Next state is 1. By reading 1, it is going to a new state Q1. By reading 1 going to the new state Q1. From Q1 reading 0 going to a new state Q2. Q2 is the final state, so we will keep 2 circles around it. From Q1 reading 1 coming to the state Q1. Q2 is the final state. Yes, we have denoted it as a final state. From Q2 reading 0 coming to the state Q2. By reading 1 coming to the state Q2. So this is a transition diagram, equivalent transition diagram for this particular transition table. Now let us define our 5 tuples over here and transition table as well. So our tuples are Q, sigma, Q0, F, and delta. So over here Q is Q0, Q1, and Q2. Over here, our sigma values are 0 and 1. For Q0, we have over here as capital Q0. For F, we have Q2. Now, Let's write our delta functions. From Q naught, it is reading 0 and going to the state Q naught. From Q naught, it is reading the input variable 1 coming to the state Q1. From Q1, it is reading symbol 0 coming to the state Q2. From Q1, reading input symbol 1 coming to the state Q1. From Q2, it is reading input symbol 0 coming back to the state Q2. Q2 reading the symbol 1 coming to the back state Q2. So again, from here, again, you can identify that Q2 is a final state because it is reading both the two symbols and coming back to the same state. This also denotes that this is the final state for this particular DFA. So this is how you can draw a corresponding equivalent DFA for a given transition function related to DFA. Let's move on and see one more example. Now, this is the example question. A DFA with sigma 0, 1 accepts all strings with 0. All strings starting with 0. So this particular DFA will accept all the strings that will be starting with 0. Now, let us understand how to answer this kind of questions. So for this, first you need to identify all the kind of strings that will be accepted with the help of this statement. So basically हमें ये जानना है यहाँ पर कि हम किन स्ट्रिंग्स को हमारे इस DFA स्ट्रक्चर में एक्सेप्ट करवा सकते हैं. So we will start with the smallest possible string. Let us write the all possible set of strings. All possible means initially आप किन states से process कराना start करेंगे अपने DFA को. So all those kind of possible set of strings will be stated for any DFA. This is the first step for drawing DFA for this kind of, or just the statements are given. So over here, smallest possible string is single 0, right? So this will be the single bit string. Next comes 00. This is 2-bit string. Now over here, it is saying that it should be starting with 0. So starting with 0 is okay. What if we get a string that starts with 1? So obviously that means that particular string should not proceed in the direction of accepting this state or accepting state, right? So over here we can accept the string 0, 1 as well, but we cannot accept 1, 1 and 1, 0. These are non-accepting states. 1 and 1, 0 are non-accepting. So we cannot accept this kind of states. Moving to the 3-bit strings. For 3-bit strings, we can accept 0, 0, 0. We can accept 0, 0, 1. We can accept 0, 1, 0. We can accept 0, 1, 1. We cannot accept 1, 0, 0. Right? Again, further also, we cannot accept 1, 0, 1. We cannot accept 1, 1, 0. We cannot accept 1, 1, 1. Right? Moving to the 4-bit, similarly, we can accept 4 times 0. We can accept 0, 0, 1, 0, 0, 1, 0. We can accept 0, 0, 1, 1. We can accept 0, 1, 0, 0. We can accept 0, 1, 0, 1. We can accept 0, 1, 1, 0. We can accept 0, 1, 1, 1. We cannot accept further starting with ones. So all the strings further from this will not be accepted in 4-bit strings. So all these are the possible kind of a set of strings which can be accepted with the help of a diagram, which will be drawn corresponding to this statement, right? So further we can write more strings, but this is enough. Now we will start drawing our DFA. Now let's draw our DFA, which will accept our smallest string over here, that is single zero. So let us draw a starting state Q0 and let's accept that state and it will be accepted. Let's say this is a state Q2 and we can randomly name the state. So it is not necessary that it should be sequenced Q0 to Q1. It is not necessary. We just need to name the state. So we have randomly named this particular state as Q2. And since we have to accept our smallest string, that is 0, so we have accepted over here this state, this string from our state. So this is the diagram or transition diagram showing the single bit string 0 is accepted. What about if we have next string that is 00? So let's draw a self loop of 0 over here. So this will accept 0, 0. Now, next we have 0, 1. What we can do for 0, 1? We need to accept the string because it is starting with 0. So let's keep, this is the final state. So we can have 1 over here. So 0, 1 is again accepted. 3 times 0 is also accepted. 2 times 0 and 1 is accepted. 0, 1, 0 is accepted. 0, 1, 1 is accepted. 4 times 0 is accepted. 3 times 0 and 1 is accepted. 0, 0, 1, 0 is accepted. 0, 0, 1, 1 is accepted. 0, 1, 0, 0 is accepted. 0, 1, 0, 1. 0, 1, 1, 0. All these strings that we have written over here in this particular set of W is all accepted. But what if we get some kind of string which is non-accepting? That should also be shown over here in our diagram. So let's draw that. So that means we have drawn the diagram for those strings which are starting with 0. Right? But what if our string is starting with 1? So let's draw a state that is accepting the strings starting with 1. But that state cannot be our final state because this particular statement for DFA will accept only those strings which are starting with 0. Now see, any string starting with 1 with will randomly, not randomly, but it will go to some intermediate state. Like for example, if we say it is starting with 1, so 1 is non-accepting state. What if we get double one? If reading 1, automatically it is going to the pathway where the string will not be accepted. So we will just keep it like this. So this is a transition diagram for this particular statement. A DFA for input strings 0, 1 that accept all strings starting with 0. So this is the transition diagram for this particular statement. Now let us draw the transition table for this and correspondingly we will write our all 5 tuples. We have 3 states Q0, Q1 and Q2. Our Q0 state is the starting state. Our Q2 state is the final state. Now let's complete this table with the help of this diagram. From Q0, reading 0. Oh, sorry, I have written A and B. It should be 0 and 1. By reading 0, it is going to the state Q2. By reading 1, it is going to the state Q1. From Q1, it is not going anywhere. That means it is some intermediate state or non-accepting state. From Q2, it is reading 0 and coming to the state Q2. From reading 1, it is again coming to the state Q2. That means again we have shown that this is our final state. Now, let's see the working of some string over here. If let's say we have a string of 0, 1, 1, 0, 1, 0. Let's see that this particular string is working on this diagram or not. It has input string Q 0. So by reading 0, it already identified that this particular string will be accepted because this string or this diagram is accepting the strings which are starting with 0. So obviously this particular string will be accepted, but how? Let's see that. From reading 0, it will come to the state Q2. From Q2, it will read 1 and come back to the state Q2. Again, it will read 1 and come back to the state Q2. It will read again 0 and come back to the state Q2. Read 1, coming back to state Q2, reading 0, coming back to state Q2. So this particular string is accepted. What if we have a string of like this, 1, 0, 1, 0? So reading 1 automatically it will go to the some non-accepting state and it is not coming to the pathway where the string is accepted. So identifying that input starting symbol is not 0, automatically this string is non-accepting state. So this is how we can check the whether our DFA is correct or not. We can have any random string which is starting with 0. So obviously it will get accepted. Starting with 1, it will not be accepted. And manually we can identify very easily, but how we can show with the help of diagram, now you can understand it very well. Now let's write our 5-tuple machine now. For Q, we have Q0. We have Q1 and we have Q2. For sigma, we have 0, 1 as stated over here in that question. For Q0, we have Q0 itself. For F, we have Q2. And now let's write our delta functions. So for delta, Q0 reading 0, going to the state Q2. Q0 reading 1, going to the state Q1. For Q1, there is no transaction function as it is going nowhere, showing 5. So need not to write any transaction function for this. Now let's write for Q2. For Q2 reading 0, going to Q2, Q2 reading 1, going to the state Q2. So this is the transition function for this particular diagram. This is the transition table for this diagram, and this is our transition diagram. This is how we can understand, or this is how we can answer any question related to DFA. Let me summarize you how the steps are followed. First, read the question, identify the strings that can be accepted with the help of the given statement or given DFA structure. By identifying the strings which can be accepted, it will be easy for you to determine how many states are required for you to show your transition diagram. And to write all those states which are non-accepting will also help you to understand and to determine how you can show all non-accepting strings. Right? So first step, always write all possible strings, at least till 4 bit of strings, which can be accepted by your DFA. This will help you to draw correct DFA. After drawing the DFA, always try to check your DFA by having any random string, as I have taken over here, W as 011010. Similarly, you can have any particular string starting with 0 and check whether it is working correctly or not. Manually, we can easily identify that if the string is not starting with 0, obviously that string will not be accepted with this diagram. But how you can write or how you can see whether this particular string is working on this transition diagram or not, always try to follow the working of particular string with your drawn diagram. So this is how you can draw any DFA for any given statement related to DFA. There is one more question over here. This is an exercise question for you all. Please try it by yourself. This DFA is having input strings of 0 and 1, which will accept all the strings ending with 0. Let me summarize the diagram over here so it will help you out further, and rest you can try yourself. So ending with 0, we will accept only those strings which will be accepted or which will be ending with 0. So let's have an initial state as Q0. Smallest string possible over here can be 0. So we have this as the diagram which will show that the smallest string possible ending with 0 is single 0. Next, if we have 2 zeros, then obviously there will be a self loop over here. So it can have any number of zeros ending any string and it will be accepted. What if we get 0, 1? If it is coming sequence of 0, 1, that means any string ending with 1, it should not be accepted. So obviously we need to track back to any state. Either we can go some intermediate state or we can go to the initial state to show that it cannot move to it cannot move to the final state if it is not ending with 0. Next, what if it is starting with 1? We have talked about if it is ending with 0 or if it is either starting with 0 also. But what if any string is starting with 1? If any string is starting with 1, must be tracking back to this state 1. Reading by 1, coming to this state, then it can follow and end with to the final state having ending variable as 0. So this is the transition diagram for this particular question. You can further try it by yourself. And if any queries, you may please contact. Thank you very much.